we ask you to calculate the volume of your contaminated soil for each of the 3 layers. We did a reclass, whether we did it in Model Builder or did it manually, in order to convert the contaminated area to a 1 and all the other areas to a 0. We finished that step with a reclass. You see on the screen a complete rectangle of buff color, which is 0, and some data inside the river. So that shows that the areas of no data that came from the very first calculation have been filled in with zeros, and in fact all of the no data out here got filled in with zeros, but I don't care. So at this point, after my reclass, I have contaminated and not contaminated. If I open up the table, which I bring over here, I have a large number of cells of 0 and a few cells of 1. Now be aware that this table, because of this big square out here, has more cells than are inside your river. But what it does have is the cells that are contaminated. So for this first layer, for me, I have 316 cells, or 316 pixels. I can turn on the next 2 layers and see the same kind of information. So my second layer has 856 cells of contaminated. So what is a cell? Well, it's the grid interval horizontally in meters. Convert that to yards, and then how thick is it? Well, we're doing a 3-foot layer, right? So it's 3 feet thick or 1 yard thick. So with simple multiplication, I can convert the 856 into cubic yards. Now I'm looking at Table 5.2 in the homework and the steps that led me to be ready to fill that table in. I used Model Builder to reclass the 3 areas, and then I multiplied the top layer by a 1, the middle layer by a 30, and the bottom layer by a 600. They still are integers, so the only choices I had was 1 times that and 0 times that. If you look on my screen, I gave my layer the interesting name total of 3 to tell me it was my kind of final result. These are the different pixels that I get when I add those 3 layers together. So we had a layer that was 600s, we had a layer that was 30, and we had a layer that was 1, and then we had 0 values around. So these are the only unique possibilities we can get. And remember, the key to this is that if there is a 3 in the tens place, that means the middle layer was contaminated. If there is a 6 in the hundreds place, that means the bottom layer was contaminated. And if there's a 1 in the ones place, that means the top layer was contaminated. So given those 3 bits of information, I can fill out the tables in 5.2. Let's look and see at our totals. So basically I'm saying I have 63 pixels in the first layer that are contaminated with nothing below them. I have 1 pixel that's contaminated, and it has a 30, so it's contaminated on the second layer as well. And I have 27 pixels that are contaminated at the surface, and they have clean dirt behind them or below them, and then at the bottom layer they're contaminated. And I have 225 pixels that are contaminated in the top layer, they're contaminated in the middle layer, and they are also contaminated in the bottom layer. So there's no overburden here. Every one of these, that when it's dug up, will be put into the pile to be incinerated. But in this case, I have 0, so I have clean dirt on the top layer, and then I have contaminated in the middle layer and contaminated at the bottom layer. So I have overburden. I have 76 pixels of overburden over those 2 sets of contaminated pixels. And that's the logic we'll use to fill the table out on the homework. I'm looking at table 6.2. Table 6.2 is a table for the logic of how we organize these. It's not a table where you're going to put numbers in the squares. We'll do that in the next table. we'll work our way through table 2 so that we understand how the layers stacked up, and then we'll use count with number of pixels to get volume in table 6.3. So a 0 value in the output raster layer I know means it's not contaminated. So I can put an N where the 0 is. Like I said, this table is going to be all yeses and nos. Where I have a 1, that meant that I had contamination at the top level. So contaminated soil, yes. And if it's a 1 by itself, it doesn't have any other depth involved, and so those are no's. Now, is there overburden? Well, if my 0 to 3 foot layer, my top layer, is contaminated, there's no overburden because there's nothing above it, and we don't have anything below it. My second layer, a 3 and a 0. The 0 means the top layer was not contaminated, so I'm going to put a no there. But the 3 means that the second layer, the 3 to 6 feet, was contaminated, so that gets a yes. And there's nothing that deep yet, so 6 to 9 doesn't count. So 0 to 3 feet overburden. Well, yes, because I have a 0, so my top layer is uncontaminated, but I still have to dig it up because there's a 3 underneath it. So that's my first overburden. Is my 3 to 6 feet layer overburden? No, because it's contaminated. And I know that because it has a 3. So that is a no. My 31 is an interesting case where the top layer is contaminated and the next layer down is contaminated. So contaminated soil, yes. Contaminated soil, yes. But this, nothing yet. Any overburden? No. Both layers are contaminated. Now I'm looking at table 6.3, and I'm going to use the logic from the other table and fill these columns in. I have arranged my table, and I have arranged underneath it the ArcMap table from my raster layers so that I can see it. I have crowded them both in the screen so you can see them. I filled in the column of count from my raster layer. And those are count is pixels, of course. So I'll show you an example or two in this table and then let you do the rest. I have 1 pixel of this category, and so that is 1 times 6 times 6, 36 cubic yards. We fill it in. We think about contaminated soil. Okay, I have a 1, so my surface layer is contaminated, so I put in 36 yards. I have a 3, so my middle layer is contaminated, so I put in 36 yards. That's all I have, so there's a 0 for the deeper depth. And because both of those layers were contaminated, I don't have any overburden. So you see what we're doing is we're calculating the total volume, putting it here, and then each time you use that, you put the same total volume in over here. In other words, a 3 and a 1 represents 2 layers. And so that volume gets used twice. It'll either be twice over here or once over here and once over there. Let's do this one down here. A 6, a 3, and a 0. And I have 76 pixels, which is 2,736 cubic yards. The 0 means that I'm not contaminated at the surface. And if I'm not contaminated, then I must be overburden. The 3 means I am contaminated at the 3 to 6 feet. So I put in 2736. Remember, I'm not putting in 76, the pixel count, and I'm not putting in 630, the value. I'm putting in the volume. 6 to 9. Well, yes, I have a 6 in my figure, so that means my 6 to 9 foot level is also contaminated. So I have 1 overburden and 2 contaminated volumes out of that one category called 630. And that'll have 0 there. So I think you can do the rest of the table in a similar fashion.